So now we're going to talk about the intersection of three planes. Last lesson was about the intersection of two planes. Today we'll upgrade to three. Let's just go ahead with an example problem. Let's see. So let's say plane 1 is 2x plus 3y minus 4z equals 4. Okay. And then plane 2 is, so I'm going to call that equation 1 for plane 1. Plane 2 is 3x minus 5y plus 6z equals to 3. Plane 3 is, let's say, negative x plus 6y, plus 2y minus 5z equals negative 1. I'll call that equation 2 and I'll call that equation 3. First thing we want to figure out is, are there any intersections at all? If there aren't, we just put no as the answer and we move on, right? So how do we do so? Well, we just try to solve the equations. We solve the equations by eliminating the variables. So we try to eliminate the variables. So which variable should we eliminate? Let's just try to eliminate variable z. So we can't do this all at once, so we'll try with the first and second equation. We'll try to eliminate z from the first and second equations by doing some operations. So looking at this, one way to eliminate is if we have 3 times equation 1 plus 2 times equation 2. So 3 times equation 1 gives 6x plus 9y minus 12z. And then 2 times equation 2 gives 6x minus 10y plus 12z. And then 3 times 4 is 12, so that's 12, and then 2 times 3 is 6. So, and then if we add this together, we get 12x minus y is equal to 18. So that's what we get. So it seems like that. So we've eliminated a variable. It seems like that the plane 1 and plane 2 planes 1 and 2 have an intersection of a line, because this equation has infinite many solutions. For example, one solution can be, x equals 1 and y equals negative 6. That gives us 12 minus negative 6, which is 18. So here we're going to try to eliminate the variable. So we're going to try to do the same thing. I'm going to call this 4. We're going to try to do the same thing by eliminating z for equations, let's say 1 and 3. So for equations 1 and 3, something we can do is we can have 5 times 1 plus, or 5 times 1 minus 4 times 3. That actually gives, so 5 times 1 is 10x plus 15y minus 20z. Now minus, minus negative 4x plus 8y minus 20z. That's equal to 4 times 5, which is 20, minus negative 1 times 4, which is negative 4, which is 20 plus 4. So if we just remove the brackets, we get this, and then we have plus 4x minus 8y plus 20z equals 24. Okay, and then so the 20z's cancel out, and then we have 14x plus 7y equals 24. I'll call this equation 5. Now from equation 5, we actually see that this again has infinite many solutions, so the intersections of planes 1 and 3 are a line. So to further solve this problem, we have to figure out if so we have the intersection of 4. So intersection of planes 1 and 2, right? That's the intersection of planes 1 and 2. And then if we draw the intersection of planes 1 and 3. So let's figure out this intersection point in the middle. Or so that's one situation, which is that these two lines intersect in one point. Another situation is that they're parallel and they never intersect. And a third situation is that they're the same line. So the three planes intersect at the same line. So it looks likely that our solution is going to be a point. So let's just try that out. So to do this, we're going to solve a system of equations involving equations 4 and 5. 12x minus y equals 18, and 14x plus 7y equals 24. Now, these are equations 4 and equations 5, right? So we want to eliminate one variable. Let's just eliminate y. So therefore we know that we can have 7 times 4, equation 4, plus equation 5, and this gives us so 7 times 12 is 84x. 84x minus 7y, and then we add that to 14x plus 7y. That gives us 18 times 7, which is 7 times 8, which is 56. So 126 plus 24. And we simplify both sides. So the left hand side we have 84 plus 14x. 4 plus 4 is 8. 8 plus 1 is 9. 98x. The y's cancel out. 98x is equal to, so this gives us 150. This means that x is 150 over 98. 150 over 98 gives us, so we divide both sides. If we divide the numerator and denominator by 2, we have 75. 75 over 49. 49's, well, 49 is only divisible by 7, and 75 is not divisible by 7, so that's just the simplest fraction. So that's x. What about y? Now y is equal to, so we can plug this into equation 4. For equation 4, right? So for equation 4, we know that 12x, so 12 times 75 over 49 minus y is equal to 18. So negative y is equal to 18 minus 12 times 75. So 12 times 75 over 49. So 12 times 75 is, so 12 times 5 is 60. 12 times 7 is 84. If we sum 60 and 840 together, we get 900. So that's 900. So 18 minus 900 over 49. So the actual y is going to be, so 900 over 49. So 900 minus, so what's 18 times 49? 18 times 49 gives us, so 18 times 9 is 8 times 9 is 72. 1 times 9 is 9 plus 7 is 16. So 162. 18 times 4 is 4 times 8 is 32. 1 times 4 is 4 plus 3, which is 7. So 2 and then 8 and then 8. So we have 882. So that one is 882 over 49. That's equal to 18 over 49. So that's just our y. So that's x. That's x. That's y. So we only need z. So how do we find z? So to find z, we just plug it into one of these equations over here. Let's plug it into equation 1. Equation 1 is, so into equation 1. Equation 1 is 2x. So 2x is 150 over 49. And then, so 2x plus 3y. 3y is 54 over 49 minus 4z. Let me just check. Yeah, minus 4z. So we minus 4z. So we just write that, and then that's actually equal to, so that's equal to 4. Okay, so if that's equal to 4, then essentially what we can do is, this means that, so we simplify this. This gives us 204 over 49. This gives us 2 over 49. 204 over 49 minus 4z is equal to 4. So we know that negative 4z is equal to 4, so 4 minus 204 over 49. 4 is actually equal to, so 4 is actually equal to 4, so 4 times 49, which is 196. So 196 minus 204. That gives us negative. So that gives us negative 8 over 49. And then, so basically we have z. If we multiply both sides by negative 1 over 4, then we get 2 over 49 as our answer. So basically that's our answer. So we have the coordinates for our points x, y, z. So 75 over 49, 18 over 49, and 2 over 49 is our intersection point for all three planes. Thanks for watching. Bye.